Hi, my name is Katherine Whidden, and I'm a research scientist at the University of Utah Seismograph stations. I'm going to talk today about aftershocks and how we know when an aftershock sequence is over. This is a question we get quite a lot about the Magna earthquake sequence, especially now that we're approaching the 1-year mark. People want to know when they feel a Magna aftershock, is this really an aftershock of an earthquake that happened a year ago? Or is this a new independent event that is unrelated? So the way we tell when an aftershock sequence is over is we look at the background seismicity rate. This is the rate of seismicity, or the number of earthquakes that are happening in an area before the main shock happens. And then we compare that background rate to the aftershock rate. And when the aftershocks decrease to the point that they reach the background rate, then we would say that the earthquake sequence is over and any new seismicity occurring in this area is unrelated to that main shock. So let's look at this in a little more detail. Here we're looking at some data from the Magna earthquake sequence. These figures were put together by Maria Messimeri. She's a postdoc at UUSS. Thank you, Maria, for these figures and these calculations. So we have here our data in blue, and then a theoretical curve in black is fit to the data. So we have on the x-axis time since the main shock in days, and on the y-axis we have the daily aftershock rate. So how many aftershocks are occurring per day. These are both in logarithmic scale, which can be a little confusing if you're not used to looking at this all the time. So time since the main shock, 10 to the 0 is 1. So this is 1 day since the main shock. Okay, so everything over here is a fraction of a day. The fraction's getting smaller and smaller as we get closer to 0. And then in this direction, so after 1 day, 10 to the 1 is 10 days since the main shock, 100 days since the main shock, and 1,000 days since the main shock. We're about a year away from the main shock, 350 some odd days at this point when I'm recording this. So we're in the 100 range. So there's 100, 200, 300, 400, and you can see our data ends here between 300 and 400. So this is where we are in time. And for our daily aftershock rate, same thing, 10 to the 0 is 1. 1 aftershock per day right here. These numbers get big, closer to the main shock, more aftershocks per day, closer to the main shock. But we want to know about the small numbers when this is going to be over. So 10 to the minus 1, that's 0.1 aftershocks per day. That's equivalent to 10 days per aftershock. So only 1 aftershock in 10 days. 10 to the minus 2, this is equivalent to 100 days per aftershock. I should mention here that we're talking only about aftershocks of magnitude 1.5 or greater. This is called the magnitude of completeness, MC. We do record much smaller earthquakes than 1.5. But when we're doing catalog statistics like this, it's helpful to pick a bottom cutoff number and only consider aftershocks of a certain magnitude or greater to keep the statistics consistent. We're using 1.5 here. So when I say 1 aftershock in 10 days or 1 aftershock in 100 days, I don't mean all aftershocks. I mean only those of 1.5 and greater. It turns out that for Magna, the background rate is 1 earthquake in 5 months. So before the Magna main shock happened, the Magna area only had 1 earthquake, magnitude 1.5 or greater, every 5 months. And we need to translate that to a daily rate, so we can put it on our graph here, and that happens to translate to 0.007 earthquakes per day. So that's what this line is here. So if we follow our background rate over to our theoretical curve and see where these intersect, it's a little bit off our chart here, but we can get a pretty good idea of where those would intersect. Follow this down to get the time when this will be over. We're in the 10 to the 3, which is the 1,000 day range. So we have 1,000, 2,000, 3,000, 4,000, and our line over here is probably 5,000 to 6,000 days since the main shock. That's when we can expect this aftershock sequence to be over. So 5,000 to 6,000 days. How long is that in years? Well, it's longer than a decade. It's kind of a long time. So we will be recording these aftershocks for quite some time. Now there is a lot of scatter in this data. You can see that not all of these points plot exactly on the line, and it is possible that we could reach that background seismicity level before a decade is up. As we continue to collect more data, we'll be able to make that estimation more precisely as time goes on. But it is safe to say that we'll be recording aftershocks for Magna for years. Now, that doesn't mean you'll be feeling aftershocks for years, because as time goes on, the probability of the larger aftershocks decreases. Maybe another question we can ask is, what is the probability that we will feel Magna aftershocks in the next year? So to answer this question, I'm turning to the USGS, who provide an aftershock forecast for events like Magna. This is all publicly available. Here's the webpage that I'm accessing here. They update this forecast pretty frequently. This last one was updated March 3rd. It's just last week from when I'm recording this. And by the time you're watching this, maybe they will have updated it yet again. So we have the magnitude ranges over here from magnitude 3 to 7. And then across the top, we have some time periods. Down here are the probabilities that you will experience a aftershock of this certain magnitude in this time period. So we're going to focus on 1 year time period, and we'll start with magnitude 3 or greater. This is about the magnitude where people will start to feel an earthquake. Sometimes smaller. We've had several magnitude 2 earthquakes in the Magna sequence that people have felt, myself included. It can be smaller, but we're starting with magnitude 3, and in the next year, this is starting from now. So 1 year from now, or from March 3rd, the probability of a magnitude 3 aftershock of the Magna sequence is 31%. That's a pretty good chance. That's a 1 in 3 chance there will be a magnitude 3 or greater aftershock from Magna. What about magnitude 4? So we've had several magnitude 4 aftershocks. Maybe you felt them. They gave the whole valley a pretty good shake. What is the probability of one of those in the next year? It's about 4%. That's pretty low, but it could happen. It's not completely out of the question. This is within the realm of possibility for sure, but probably won't happen. So what about larger aftershocks? Magnitude 5, that would be larger than any aftershock we've recorded so far for Magna. And then of course, 6 and 7, larger than the main shock itself. These are all a less than 1% probability in the next year. So we never say never, but it's very unlikely that we would have an earthquake or an aftershock magnitude 5 or greater for Magna. So it's important to remember that these numbers, everything I've talked about so far, is specific to Magna and the Magna earthquake sequence. This does not say anything about our probability of having a magnitude 5 or 6 in Utah or in the Wasatch Front in general. This is only about Magna. We still live in earthquake country here in Utah, and we can still have a large damaging earthquake at any time. So here's a figure and some statistics put out by the Working Group on Utah Earthquake Probabilities. So in the next 50 years, there's a 43% probability of a magnitude 6.75 or greater earthquake. That would be the big one, 6.75 or greater. In that same time period, in the next 50 years, there's a 57% probability of a magnitude 6 or greater earthquake. So that would be more damaging than Magna. 57% chance in the next 50 years. That's a lot of statistics and numbers. Another way you could think about this is in our lifetimes, if I'm doing some creative rounding and saying that our lifetimes are about 50 years, in our lifetimes, there's about a 50% chance that we will experience a large damaging earthquake. So that's kind of a lot. That's a coin flip whether you will experience a large damaging earthquake in your lifetime. So what are we going to do about this large earthquake that has a 50% chance of happening? The best thing you can do for earthquake preparedness is to have food, water, and medicine for your family for 2 weeks. That's the number one thing. There's a lot of other things you can do. If you want to know about earthquake preparedness, I encourage you to go to earthquakes.utah.gov. You can also go to our website, follow us on Twitter. There's a lot of information out there and a lot of things you could do if you want to know more. So bottom line, the Magna sequence is still ongoing. We will continue to record Magna aftershocks for quite some time, probably years. We may or may not continue to feel them. We'll have to stay tuned and see what happens. As always, we live in earthquake country and we can have a large damaging earthquake at any time. The best thing you can do is be prepared. Evaluate your stores, see where the holes are, and fill them in as needed. Thanks for watching.